All right, friends, welcome back. So now we're talking about why the seasons changed. It's part of our unit talking about the sun and the power of the sun. And we talk about why the seasons changed. And of course, that's a combination of a couple different factors. Now, before you get into it, ask your kids, why do seasons change? Get them to talk about their misconceptions. They won't know it's a misconception. They'll just come up with these answers. Why do seasons change? Work them in small groups, have them talk about it, have them write it down. You can throw them up on the board. Why do seasons change? They come up with their answers, and then we can go back and we can start dismembering. That sounds more graphic than it should be. Taking apart their ideas and coming up with a better, more logical approach, and you can show them where their ideas fall short of facts. Okay, so you can list them on the board. The most common reason they have is because the Earth is getting closer to the sun, and therefore we're getting warmer, and that's why it's summer versus winter. Okay, so they're confused about the way the orbit of the Earth is around the sun. Now, of course, to some extent, it's slightly true in the sense that Earth has an oval orbit. All the planets do. None of them are perfectly circular. They're all oval to some extent. So at some points we're slightly farther away, at some points we're slightly closer. But considering that we're 93 million miles away, that slight difference doesn't make much difference in terms of the actual temperature that we have. But in order to describe it, to get them to work with materials and get them to see how this works, it's hard to do in a model. So this is the model we have. You take some graph paper, a flashlight. So the flashlight's going to be, in our model, the flashlight's going to be the sun. They need a Sharpie or a marker of some kind, and they need a ruler. And you have to do this with partners. And what you're going to do is you're going to hold the ruler down, and you're going to put the flashlight on the end of that ruler, and you're going to shine it down onto your graph paper. And they're going to use a Sharpie to draw a circle around the light part of that. So it's kind of the opposite of a shadow. So where's the light on this graph paper? I'm going to hold it straight up and down. Now, if they hold it straight up and down, that's going to be like the sun in summertime, where the sun is high up on the horizon, high up in the sky. You get almost at noon, for instance, during the summer equinox, for instance, you will have light coming almost perfectly straight down on us. Now, that means a lot of light in a small area. However, when they need to show two more ways. So they're going to hold it straight up and down, 90-degree angle. They'll show the light, and they're going to draw a circle around the light. They need to show it two other ways. At about 135, and we're estimating here, they don't need a protractor. You can get them a protractor, but they don't need to. So if this is a right angle, about halfway down, okay, so about 135 degrees. And the last one will be about 170. So the flashlight is like here the first time. It's tilted like this the second time, maybe 135 degrees. And then it's tilted like this the third time. And each time we're showing a circle of light on this piece of graph paper. Now, you don't want to draw the entire circle, but there's usually an inner circle of the flashlight. And you can talk to them about this, because otherwise you need a much larger piece of paper, which you can do, but the second part of this will become more complicated. And you need a piece of graph paper, because what you're trying to get them to do is find the area. Okay. Now, in upper grades, of course, they can measure the radius of this, and they can find the area of the circle with using some math. But your kids aren't quite there yet. So we're going to use the graph paper, and we're going to concretely count up the number of squares inside of this. Now, let me give you a suggestion on that. So, and they should label it 170, that's where the flashlight's almost all the way down. So this is flat, like this. 135, it's about halfway up, and 190, or 90 is straight up and down. So here's my three circles, and they can be on the same side of the paper or not. If they are to write it on this graph paper, if they start counting each of these circles one by one, they're going to lose track, and they'll start over, and they'll drive themselves crazy. After a while, they'll give up, and it won't work. So the best way to do something like this when you're trying to count a whole lot of squares is keep it simple. and they can't fill it in. They can't, if they try to fill in each one, it's going to take forever. So they just need to put a dot in each circle, and they need to count. Now, some of these are squares on the graph are not going to be complete. They don't have to count those if you don't want them, or you can have them kind of round up if you want to talk about it that way. Otherwise, just can't go with only the full squares. It's up to you. Count the full squares if you want. So 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm just putting a dot. I'm just touching it so I can keep track. And then I get to the end, and I don't want to put a dot on the 10th one. I want to put X. Okay, so I want to put an X on each 10th one. Now I start over. 1, 2, 3, 4, 5, 6, 7, 8, 9. Put an X. I don't care how many X's I'm doing yet. I just count to 10. I start over. 10 or 9X, 9X, 9X. I just keep going all the way through there. Okay? It's easy to count that way. If I lose track, I just go back to the last X, start counting backwards again. I don't lose all the numbers. Okay? When I am done, I go through and I count just the X's. Now I'm counting my 10s. 10, 20, 30, 40, 50, 60, 70, 80, 90, 150, whatever it is. And then I write that down. Okay, so this was now, let's say 362 X's, or bits. Okay? Now, if you don't want them to have to worry about the last one, you can just say count by 10s, and then just go with 360, whatever it happens to be. Whatever's easiest for you. There'll be enough difference between this that you won't have to worry about the ones number. What they'll find out is that when the sun is low in the sky, it has to cover a much larger area. So it's the same amount of heat covering a larger area. So this is the sky in wintertime. Direct sunlight is the sky in summertime, and the light's coming straight down. They can feel the heat. You walk outside in the summertime, you feel that heat hitting you in the face, right? You can feel it on your skin. In the wintertime, you go outside, you don't feel it at all. Same sun, same distance to our Earth. The difference is that light is spread over a much larger area. And then here in spring and fall, it's kind of in between. It's got some heat, but not nearly as much. Okay? So this is why we have the seasonal change. So the reason you have the sun putting out that amount of heat, but in a larger area, is because of the axis tilt. So if you were to try to write a description about why the Earth changes the seasons, it's because the tilt of the Earth, as it revolves around the sun, is giving us the seasons. Now, why is the Earth tilted? Best we can tell the Earth is tilted is because when a planet several billion years ago smashed into the Earth, it both tilted our Earth, so it's now off axis, it's not straight up and down, and created the moon. So that same impact gave us the seasons and gave us the moon. Both those things were actually fairly important in terms of being able to diversify life and or generate life in the first place. So we can be very thankful that this planet came in and partially destroyed our planet or reset it back into a giant ball of lava. And then we can now be very happy about it. I'm sure it wasn't a very happy event at the time, but it made life on our planet much more likely, if not possible. Now, in terms of that axis tilt and the seasons, if you talk to your kids more about, okay, they're not getting it, they don't quite understand it, remind them that when you have summer in the northern hemisphere of the Earth and in the southern hemisphere of the Earth, that the season is backwards, that it is wintertime. And if this were just about the distance of the sun and the Earth together, so here's my Earth, here's my sun, we come together, now it's summertime, we move apart, now it's wintertime, we should have the same seasons, both North and South Pole should be the same seasons, it should be summer for both of us because we move the entire planet closer. But of course it's not. Summer on one hemisphere, winter on the other. And that's just one more fact to be able to show them, no, it's not the distance from the Earth to the sun, it is in fact how the Earth is tilted. All right, thank you so much.